Okay, so picture this. You walk into a library, and instead of grabbing a novel or a biography, you pick up a city planning guide.
Right.
It's thick, it's dense, and it details everything from like the sewage system to the electrical grid. Most people would probably just put it right back on the shelf.
Yeah, it's not exactly light reading. It's a reference manual.
But today, that is exactly what we are doing. We're looking at a map, not of a city, but of the ecosystem that powers a huge chunk of the software world. We're doing a deep dive into the documentation for the Spring Framework, version 6.0.7.
And to be clear, we are not reading code today. We're not, debugging anything. We're just looking at the table of contents.
Which I know sounds incredibly dry. But when I open this PDF, Spring Framework 6.0.7.pdf, it really struck me. The way this thing is organized, it's not just a random list of features, it's a narrative. It tells a story about what really matters in modern software.
It absolutely does. And even before you get to the table of contents, you see the names. Rod Johnson, Jürgen Haller, and a list of over 30 other contributors.
It's like the credits of a Marvel movie, but for Java developers.
It really is. It represents this massive legacy. I mean, Spring has been around for, nearly 2 decades now? So version 6.0.7 implies a huge amount of evolution. This isn't some trendy new thing that popped up last week.
Right.
This is battle-hardened technology, and the structure of this document reflects lessons learned from, thousands of projects.
So our mission today is to decode this map. We want to see what Spring prioritizes, how it divides its world, and honestly, just appreciate the sheer number of tools they're handing us. And looking at the map, we have to start at the foundation, Section 3.
Section 3, Core Technologies.
It doesn't start with how to build a website, which is where most tutorials start. It starts with Section 3.1, the IOC container. Why is that the very first technical stop?
Because without the IOC container, Spring, as we know it, just doesn't exist. It's the atom of this universe. IOC stands for Inversion of Control.
Okay, let's break that down, because inversion of control sounds very academic, but the concept is actually pretty practical, right?
Yeah, think of it like a general contractor on a building site. If you're a plumber, let's say you're a class in Java, you don't go out and find the electrician yourself. You don't manage their schedule.
You just show up.
You just show up, and the general contractor tells you, here's the electrical line you need to work next to. The control is inverted. You aren't calling the shots. The framework is.
And in the documentation, in 3.1.1, they introduce beans. So, in your analogy, the plumber is a bean.
Exactly. A bean is just a fancy word for an object that is instantiated, assembled, and managed by that general contractor, the Spring container. And they put this right at the front because everything else, databases, web, security, it's all just beans being managed by the container.
So if you don't get that, you're lost.
You're completely lost. If you look at the subsections, you see dependencies and bean scopes. This is Spring telling you, before you do anything else, understand how we manage the lifecycle of your objects.
But Section 3 isn't just the container. It felt more like a utility belt. I was looking at Section 3.2, resources.
That is a great example of Spring just solving boring problems. In raw Java, reading a file from the file system versus from a URL requires different code. It's just an annoying little inconsistency.
Right.
So Section 3.2 is Spring saying, look, here's a resource interface. We don't care where the file is. Just use this one way to get it.
It abstracts away the plumbing. And then you have Section 3.3, validation, data binding, and type conversion.
Also critical, data coming into your app is messy. It's just strings and JSON from a browser. You need to turn that into, strict Java objects. This section details how Spring handles that conversion.
So it's the translation layer.
Exactly, between the messy outside world and your clean code.
Then there's 3.4, the Spring expression language, or SpellLL. I always see this in the code, those little curly braces with the hash sign. But I never realized it was like a standalone pillar of the core.
SpellL is incredibly powerful. It lets you query and manipulate your objects at runtime. You can say things like, inject this value, but only if this other bean is active. It makes the configuration dynamic.
Okay, and we can't skip 3.5. Aspect-oriented programming, AOP. This is one of those concepts that feels like magic when you first see it.
It is a bit magical.
Yeah.
AOP is all about separating what they call cross-cutting concerns.
Cross-cutting concerns. Okay, that's the jargon. What does that actually mean?
Okay, so imagine you want to log how long every method takes to run. Without AOP, you'd have to write logging code at the top and bottom of every single function.
Oh, that's a nightmare.
It's a nightmare, and it clutters your real business code. With AOP, you write the logging logic once, and you just tell Spring, Apply this to every method in this part of the application.
So it just sort of weaves that code in for you.
Exactly. It keeps your business logic clean. You
Yeah.
focus on the banking transaction, and Spring AOP handles the security check and the logging in the background. The fact it's in the core section tells you it's a fundamental concept. Okay, so we've got our foundation. We have the container, resources, AOP magic. Now, normally my instinct would be, okay, let's build the web page or let's save some data. But the table of contents throws a massive curveball here. Section 4 is testing.
I was hoping you'd catch that.
It's before data access. It's before the web. That feels very intentional.
It is a deliberate philosophical statement. By placing testing right after the core and before you build any real features, the documentation is basically screaming that reliability is paramount. You don't build, then test. You build for testing.
And looking at the breakdown, it's not just here's how to run unit. It's really comprehensive. Section 4.2 covers unit testing with mock objects.
Right. And then section 4.3 covers integration testing. And this is where Spring really shines. Look at the subsections there: context management and transaction management.
Wait, transaction management in tests?
This solves the hardest problem in integration testing. So let's say you write a test that saves a user to the database.
Yeah. Now your database is dirty. There's a fake user in there. The next test might fail because that user already exists.
Right, so you have to write more code to clean it up afterwards.
Which is error prone. Section 4.3 explains how Spring's test framework handles this. It starts a database transaction before the test, lets your code run, and then automatically rolls it back when the test is done. The database is never actually changed.
Wow. So it's like it never happened.
It's like it never happened.
Yeah.
That is a huge productivity booster.
Yeah, you're not spending half your time cleaning up your own mess.
Exactly. And then you see specific tools like Web Test Client in Section 4.6 and MockDVC in 4.7.
I've used MockMVC. It basically lets you pretend you're sending an HTTP request, but without actually running a server, right?
Correct. It bypasses the whole network stack. It mocks the entire HTTP cycle. This means your tests can run in milliseconds instead of seconds. It's the reason developers can do test-driven development effectively in Spring.
So the aha moment for Section 4 is that the framework is a safety net. It's not just giving you bricks to build a house, it's giving you an inspector to make sure the walls don't fall down.
And only after you have your core and your safety net are you allowed to enter the engine room. Section 5, Data Access.
This section felt like a history lesson and a glimpse of the future all at once. But again, the ordering was surprising. Section 5.1 is transaction management.
Are you sensing a theme here?
I am. Before they tell you how to get the data, they tell you how to protect its integrity.
Because data consistency is everything. If a bank transfer fails halfway through, it's a catastrophe. Section 5.1 explains how to manage this declaratively.
That's the @transactional annotation.
Yep. You just tag a method, and Spring makes sure that either everything in that method happens or nothing happens. It hides all the complexity of database commits and rollbacks behind a single word.
Okay, so speaking of how we talk to the database, this section seems to act like a universal adapter. You've got Section 5.3, data access with JDBC. That's the classic way.
That's the bedrock. The JDBT template. If you've ever written raw JDBC, you know it's verbose and painful. The JDBC template removes like 80% of that boilerplate. It's for people who want total control of their SQL.
But then right next to it, Section 5.4 is data access with R2DBC. That sounds new.
It stands for Reactive Relational Database Connectivity. This is the cutting edge.
Reactive, we're going to hear that word a lot. What does it mean for a database?
So traditional JDBC is blocking. You send a query, and your application thread just sits there and waits for the database to answer. R2DBC is non-blocking. You send the query, and you immediately go on to do other work. When the data is ready, the database pings you back.
So it's the difference between standing in line at a coffee shop waiting versus taking a buzzer and sitting down until it goes off.
That's a perfect analogy. And in high-scale systems, that difference is massive.
But it doesn't stop there. Section 5.5 is Object Relational Mapping, ORM. This is where Hibernate and JPA live.
Right. For developers who don't want to write SQL, they just want to save their Java object, and the ORM translates it for them. Spring integrates with it seamlessly.
And then tucked away in Section 5.6 is marshalling XML.
Which is what I mean about the map showing history. XML isn't cool anymore. Everyone wants JSON, but, banks, healthcare, insurance, they run on XML. And Spring 6.0.7 still fully supports it.
It really is a one-stop shop for data then. Raw SQL, reactive streams, ORMs, even old XML.
And that diversity sets the stage perfectly for what I think is the most striking feature of this whole document, the Great Divide.
Yes, this was the thing that jumped out at me the most. We get to the web layer, and the documentation just splits into two parallel universes. Section 6 is web on servlet stack, and Section 7 is web on reactive stack.
This is the central choice of modern Spring development.
Okay, let's walk through Section 6 first, the servlet stack. This is the classic Spring web, right?
Correct. Section 6.1 introduces Spring Web MVC and the Dispatcher Servlet. If you've done Java web dev in the last 15 years, this is your home. It's built on the Servlet API.
Which uses that blocking model you mentioned.
Exactly. One thread per request. It's stable, it's incredibly robust, and it runs on standard servers like Tomcat.
And looking at the features in there, it's loaded. Section 6.1.3 has annotated controllers. 6.2 covers REST clients like REST template.
REST template is the old workhorse. And look at the view technologies in 6.1.11 Timeleaf JSP. Even PDF and Excel generation is baked right in.
So if you're building a standard corporate website or dashboard, Section 6 has you covered.
The whole 9 yards.
Okay, so that's Universe A, the classic, robust servlet world. But then we cross into Section 7, web on reactive stack.
Welcome to the non-blocking world. This is built on what they call Spring Web Flux, which you'll see in Section 7.1.
And how is this different?
Well, instead of the dispatcher servlet, Section 7.1.3 introduces the dispatcher handler. It runs on an event loop, kind of like how Node.js works. It can handle a massive number of connections with a tiny number of threads because it never blocks.
And instead of REST template, Section 7.2 gives us the web client.
Exactly. The web client is the modern, non-blocking way to make HTTP calls. And interestingly, a lot of people using the classic servlet stack still use web client now just because it has a nicer API.
I noticed another comparison that really highlighted the difference. In the servlet world, Section 6.4, they have standard WebSockets. But in the reactive world, 7.6, they have something called RSocket.
RSocket is fascinating. It's a protocol designed from the ground up for reactive streams.
How is it different from a normal WebSocket?
A standard WebSocket is just a pipe. You push messages through it. RSocket introduces the concept of back pressure. Back pressure. Imagine you're a server sending data to me, the client. If you send it faster than I can process it, I'm going to crash. With RSocket, I can tell you, the server, hey, I can only handle 5 items right now. Pause. And you pause. It creates a much more resilient streaming system.
That is incredible. So Section 7.6 is fully dedicated to this high-end streaming capability.
It shows Spring isn't just following trends, it's implementing these complex protocols for high concurrency systems.
So the aha moment here is that Spring doesn't force you to pick a side. It gives you a full, mature ecosystem for both. If you need the traditional blocking style, use Section 6. If you need high-scale streaming, Section 7 is your guide.
And crucially, they share a lot of concepts. You still use things like edget mapping in both. The code looks very similar.
That's a huge relief for someone learning this stuff. You don't have to relearn everything.
Precisely. You just change the engine under the hood. It lowers the barrier to entry.
So we've built the core, tested it, connected to data, and picked our web universe. What's left? Well, Section 8, integration.
I like to call this the batteries included section.
It really feels like that. It's a collection of all the things you eventually need in a real application, but, usually hate setting up.
Like what stood out to you?
Section 8.4, email. I mean, it's just there.
Sending email in Java with the raw APIs is surprisingly verbose.
Yeah.
You're dealing with MIME types and session properties. It's a mess.
Yeah.
Section 8.4 gives you the mail sender. It simplifies the whole process down to a few lines of code.
It's a classic Spring move. We know you're going to need this, so here's a clean abstraction for it.
Yep.
And then there's Section 8.5, task execution and scheduling.
This is critical. Almost every app needs to run a background job, like clearing a cache every hour or sending a report at midnight.
Right, and usually you'd need a whole separate library for that.
You can, but Section 8.5 gives you the add scheduled annotation. You just put that on a method, say add scheduled, fixed rate equals 5,000, and Spring runs it for you every 5 seconds. No config files, no mess.
I also saw Section 8.2 JMS and 8.3 JMX.
So JMS is the Java message service for connecting to message queues like ActiveMQ. It's how big enterprise apps talk to each other asynchronously. And JMX is Java Management Extensions.
That sounds like admin stuff.
It is. Section 8.3 shows you how to export your beans so you can monitor them. It's all about observability. You can see things like how many database connections are open or how full is the cache right inside the running application.
It's impressive how they really do try to cover the whole integration picture. It's not just your code, it's how your code talks to email servers, message queues, and scheduling systems.
And it creates a cohesive experience. You're not trying to cobble together 20 different libraries from 20 different vendors. You're staying inside the Spring ecosystem, using the same patterns for everything.
So, looking back at this map, this table of contents, it really is a journey. We started at the core IOC container in section 3, realizing that managing objects is the root of everything.
Then we saw the massive emphasis on testing in Section 4, establishing reliability as a core value before we even touched a database.
We dove into the engine room of data access in Section 5, seeing how transaction management is king, whether you're using classic JDBC or the futuristic R2DBC.
We navigated that great split between the servlet and reactive worlds in Sections 6 and 7, which offers developers a real choice.
And finally, we wrapped it up with Section 8, the integration layer that connects our app to the rest of the world with email, JMS, and scheduling.
It's a comprehensive picture. And I think what this 6.0.7 documentation proves is that legacy and innovation aren't enemies. They can live in the same PDF. You have XML and JDBC sitting right next to reactive web clients in RSocket.
That is a really powerful thought. It's not about throwing away the old to make room for the new. It's about expanding the map to include both. It lets a company maintain their 10-year-old system while building a new real-time service, all with the same framework.
Exactly. It respects the investment you've already made while still giving you a clear path forward.
So here is my challenge to you, the listener. We've given you the overview of the map, but a map is useless if you don't explore. Pick one section we talked about today. Maybe it's the reactive web in section 7, or maybe you want to finally understand how transaction management really works in 5.1. Open the doc, find that section, and take your own deep dive.
You might be surprised at how readable it actually is. It's not just technical specs, it's a guidebook.
Thanks for listening to this deep dive. We'll catch you next time.
Goodbye.